In today's series, we are going to be dealing and talking mostly about carbohydrate. But first, before we begin today's, I'll first of all want to make some setting definition very simple. When we talk about carbohydrate, of course, the key term here, carbohydrate, simply means that carbon that has been hydrated. In other words, carbon which water has been added to it. I will share with you a simple formula which is going to represent this carbohydrate as a hydrated carbon so that we are going to see the different types of carbohydrates in terms of the number of carbon which is being found in its formula as a general formula. Let's look at this simple representation of carbohydrate as a simple formula in terms of CHO2. That is carbon which water has been added to it. And since we have talked about carbon which has been hydrated, therefore we are looking at this formula, carbon like this, which has been hydrated. It means that water molecule has been added like this. It has this general formula, but here we are going to put the water in the bracket and represent this C as X in this area, and we are going to put Y at the outer part of this section. Therefore, we are talking about carbon which has been hydrated. You can see water molecule and the carbon itself. This is the general formula for carbohydrate, and the C which is outside here, as you can see here, represent the number of carbon where X and Y can be variable. That is, X and Y are variables. This variable simply means that if we use X for 2 or 3 or 4, it is going to represent the number of carbon. If X, for example, here, if we state that X is equal to 3, therefore we are talking about triose, that is 3, which is tri. If it is 5, we are talking about pentose. Therefore, if we are being asked to represent this as in the form of the number of carbon, if the number of carbon here is 3, we are going to therefore say the X will be represented by 3 and the Y will be represented by 3. In other words, we are going to say, let's assume 3 for X and also 3 for Y. Therefore, we are going to have C3, and since we have H2O in the bracket, we are going to say 3 here. You can see this Y is also 3 as the variable. Therefore, we are going to say 3 times 2, which is going to be 6. Therefore, we are going to have H6 and O, as you can see here, 3. It is going to be like this, which is still the same as C3, H6, O3. This is the triose, as you can see here. Therefore, we are going to call this as trioses. This is a carbohydrate which is triose. And of course, if the X or the Y is equal to 4, then of course, we are going to have what is called, or 5, we are going to have pentose for 5. So it depends the number of carbon which we are going to represent here from the outside as the formula in general. Therefore, we have sugar, or we have monosaccharide as carbohydrate, which in this case we have trioses, we have pentoses, and we have hexoses, where the trioses or the pentoses and hexoses represent the number of carbon in terms of the number. If it is 3, then it is trioses. If it is 5, it is pentoses, which in this case, if it is 5, then we are going to use this same general formula, which you can see here. This time, we are going to say C, which this X here is going to represent 5 as an example. We are going to have 5 here. Then 5 will be outside here for Y. 5 times 2 will be 10, which is the number of hydrogen here is going to be 5 times 2 is 10. And the number of oxygen here is going to be O5 here, which this is going to represent pentoses, as you can see here. This one here is trioses. This one is trioses as the sugar, or is monosaccharide trioses. So just as you have seen, carbohydrate, which is hydrated carbon, is being represented by the general formula C in bracket H2O, and the C has X and the bracket outside has Y, which are variables. And these variables represent the number of carbons. If the number of carbon is 3, then we are talking about tri, which is trioses, is a monosaccharide. If it is 5, which is 5 carbon, therefore we are talking about pentoses. And if it is 6, we are talking about hexoses. In these cases, we are going to make sure that we multiply the number of the variable, which is in case where it is trioses, which means 3 carbon, then Y also has to take the variable 3, which we have to multiply to have the number of hydrogen and oxygen to make that sugar or to make that monosaccharide in terms of either trioses, pentoses, or hexoses, which we have just mentioned. Therefore, if you hear the word carbohydrate, this simply means carbon which has been hydrated, and they have the general formula CxH2O in bracket Y, where X and Y are variables representing the number of carbon for C, and the variable outside, which will be represented as a number, will be multiplied by the number of elements in the water molecule, just as we have explained previously. This therefore takes us to the final state of the fact that whenever you hear the word carbohydrate, it is therefore made up of 3 main elements. Carbohydrate is made up of 3 main elements. First is carbon, second is hydrogen, and third is oxygen. These are the 3 main elements of carbohydrate. Now, let's look at some of the properties of carbohydrate. And I'll state 3 main properties of carbohydrate when it comes to this aspect. First, you need to know that all carbohydrates are aldehyde. This is the first property. I will explain exactly what it means, and I will draw a structure to show you what it means aldehyde. The next property is to note that all carbohydrates are ketones. That is, they can either be aldehyde or ketones. Therefore, all carbohydrates are either aldehyde or ketones. The next property of carbohydrate is the fact that all carbohydrates contain hydroxy group. And I will share with you the meaning of this. When we talk about hydroxy group, it is the OH group. But I will show you the difference between aldehydes and ketones. Therefore, when we talk about all carbohydrates are either aldehyde or ketones, we are talking of this group which I'm going to represent. When we talk about aldehyde groups, we are talking about representation of these CHO, as you can see here. This is an aldehyde group, as you can see, and it is being represented like this by this formula, where we have the carbon being linking to oxygen by a double bond, and also it is being linked to hydrogen itself, as you can see here. But when we talk of the keto group, we are talking about carbon in 3 chains as an example, where the central carbon, as you can see here, is being linked to O by a double bond. And we have the hydrogen group now being linked to the other carbon atoms. So you can see this is an aldehyde group, as you can see here, and this is a keto group, as you can see here. We also have the hydroxy group, which is an OH group, and of course, the hydroxy group is being represented, as you can see, it is the OH group, and it is usually being attached to carbohydrate. So I will draw some simple structure to demonstrate to you how these group names come about in terms of the fact that we can recognize either the keto group or the aldehyde group in some structures of carbohydrate. So the first structure we are going to use to demonstrate the presence of aldehyde group is in the structure of glyceraldehyde. You hear the name glyceraldehyde. I will spell it glyceral like this, glyceraldehyde. You can see glyceraldehyde. This is the aldehyde group here. So I will draw the structure of glyceraldehyde, and we are going to recognize the aldehyde group in the structure. So in the structure, I'm going to represent 3 carbons like this. And in these 3 carbon, we have the first carbon being linked to the O group, as you can see here, and now to H group. Then the rest of the carbon here will be linked to the hydroxy group, as you can see here, to the hydroxy group, and the rest will be linked by the hydrogen group here. And of course, when we talk about the aldehyde group, you already know from the first start, which I stated, that this is the aldehyde group where the C is being linked to oxygen or to O by a double bond and is also linked to hydrogen. So in this structure, which is glyceraldehyde, you're going to see that this is the aldehyde group here. Why? Because this C is linked by a double bond to O and also linked to H, which if you see here, this is the aldehyde group. Therefore, the aldehyde group is here. That gives the structure of this as glyceraldehyde. Now, at this point, there is something you should note, which is one of the hydrogen group which I have not attached to the last C, which is the carbon at the end here. So in your own structure, make sure that you include the hydrogen bond or atom linked to carbon as the last carbon, which is the 3rd carbon. Therefore, you can see that all carbohydrates are either aldehyde or ketone. So this is an example of a carbohydrate which is an aldehyde. Example, glyceraldehyde. You can see the aldehyde group here. I will draw another structure to represent to you the formula of any carbohydrate where we have instead the keto group. And in this case, I'm going to use dihydroxyl ketone or acetone. Dihydroxyl acetone. So we are going to use this one, dihydroxyl acetone. Acetone. So we are going to use this, dihydroxyl acetone. I will draw the structure here, and we are going to make sure that we pick out the keto group from it. Remember, I stated that for a keto group, you can see here, there must be the central carbon, which is linked to O by a double bond. Therefore, the structure which I'm going to draw must make sure that the central carbon must bind to O by a double bond. So in this case, I'm going to represent it by 3 carbon. Therefore, the central carbon must be bound to O. And of course, once it is bound to O, we have now the remaining carbon being bound to hydroxy group. As you saw here, once the first carbon was bound to a double bond O, the rest of the group were hydroxy group. In this case, for dihydroxy acetone, since this one has already been bound to O, then the rest must be also bound to hydroxy group, same way as this hydroxy group, which you can see here and here. Therefore, this must be bound to a hydroxy group here. This also must be bound to a hydroxy group as well. Then now the rest of the bonds, which you can see here, must now be hydrogen bond. Therefore, we are going to represent the remaining bond as hydrogen here, hydrogen, and hydrogen. As you can see here, this hydrogen here, this is dihydroxy acetone. Therefore, the acetone group here is this part where you can see this double bond here. Therefore, if we are to find or locate the hydrogen group here, we are going to state here these 3 bonds of carbon. As you can see here, we are going to draw it like this. We are going to take to include the next step because we have set 3 bonds. Therefore, it is going to be like this. Let's specify this. You can see. So this square or this structure which we have highlighted here is the keto group. That is the acetone, the keto group. You can see for this case, this is the aldehyde group. For this case, this is the keto group. And this is called dihydroxyacetone. The reason from this dihydroxy, that is 2-hydro. This is the 2-hydro. This is the first hydro group, and this is the second hydro group, giving it a di. So di simply means 2. This di simply means 2. So the name di means 2. That is dihydroxyl. That is 2-hydroxyl. Then acetone, which is the keto group, as you can see here. That is the origin of the name. This is why we stated that the properties of carbohydrate: 1, all carbohydrates are either aldehyde or ketone. And we also stated that they have the property of the fact that all carbohydrates contain the hydroxy group. You can see based on the structure, we have the hydroxy group. Let me try to specify here. Since we have given the characteristics or properties of carbohydrate, we have stated that all carbohydrate consist of the hydroxy group. You can see for glyceraldehyde, this is the hydroxy group, as you can see. This is hydroxy group. In the next, this is hydroxy group, as you can see here, hydroxyl. And of course, you can see that on the other hand, we also have hydroxy group here. As you can see, we have another hydroxy group. Both of the two contain hydroxy group. And we have also stated that all carbohydrates have the property of either being an aldehyde. As you can see here, this is an aldehyde. Or all carbohydrates must either have ketones or keto group. This is the keto group here, as you can see. So those are some of the properties of carbohydrate. Now, as you have seen, when we talk about the properties of carbohydrate, we are talking about the fact that all carbohydrates are either aldehydes or are either ketoses. So as we have represented, you can see that all carbohydrate must also contain the hydroxy group, which is the OH group. These are the properties of carbohydrate. Now, let's look at the classes of carbohydrate. Carbohydrate is divided into 3 main classes. That is major classes. 1, we have monosaccharide. We have 2, disaccharide. And 3, we have polysaccharide. So when we talk about monosaccharide, we are talking about one of the saccharide. Disaccharide means 2 saccharide, and polysaccharide means many of the saccharide. So from the name monosaccharide, we are talking about one single sugar unit. But if we talk about disaccharide, we are talking about 2 sugar units, and polysaccharide, many sugar units. Since you already know that all monosaccharide or monosaccharide are sugars, when we talk about mono, we are talking about a simple sugar, which is a single unit of sugar. Disaccharide is double unit of sugar, but polysaccharide is many units of sugar. Therefore, disaccharide is made by joining 2 monosaccharide, and polysaccharide is being made by joining many monosaccharide. So the name originates based on either mono, di, and poly. So mono means 1, di means 2, and poly means many. So if we talk about disaccharide, we are talking about 2 of the mono. If we talk about polysaccharide, we are talking many of the mono. So these are the differences we need to note. So in the next series, we are going to talk more on monosaccharide, as well as we will proceed to disaccharide and also polysaccharide, giving some of their properties, functions, and things you should know about these different saccharides. So you want to make sure that you subscribe and also enable the bell notification icon so that you are going to receive updates whenever a new series or episode is being released. Bye-bye for now, and see you again in the next upload.